Now that we have our setup complete, we can now move on to the main modeling portion for our hook. And the first feature that we're going to create is going to be the loft feature. So as you can see, we have each one of the cross-sectional sketches completed. We have our helper surfaces visible because we will be using each one of the sketches and the edges of our helper surfaces in the loft feature. So let's look at that in more detail. It's important to select the cross-sectional sketches in order. So if we were to select the one here at the top right, then we would move over to the one here at about 4 o'clock, the one to 6 o'clock, the one at 9 o'clock, and then the one up here at the tip. If we don't do them in order, we would get an irregular shape. Another thing to keep in mind are the connectors. If we move a connector, if one of the connectors is not in the same area or spot as one previous, we might not get a preview, and that would tell us we have an error, or we would get a distorted shape. We have no start and end constraints. And then the guide curves. So we'll be using the 2next guide curve influence. The guide curves are the edges of our helper surface. So here we'll be using the outer one and then the inner one. We'll be using tangency to face. And that's the tangency between the helper surface here and then the actual loft surface that we will be creating here. There are no other options that we need to set. So let's take a look at what we would get as far as the surface is concerned. So we get a nice smooth surface around the part, conforming to the guide curves and to the cross-sectional sketches. Once the main hook surface has been created, we can move on to the tip. Now here we're going to create another draft helper surface, which is going to be controlled by 2 sketches. So let's take a look at the first sketch here in a little bit more detail. So we can see we've got a sketch line and then a construction line. The draft angle again is controlled by the global variable. We've got a pierce relationship here along the edge of one of the helper surfaces. The other sketch, which is just an arc, and it has a on-edge relationship which was taken from the layout sketch. The loft feature itself is created from the sketch, okay, and then the 2 edges on the helper surfaces. We also have some other options that we've set. We have a start constraint, which is going to be tangent to the face, so tangent to the helper surfaces between the 2 faces here on both sides, so the start and end. The tangency length is controlled by these arrows or by a numeric input, so we can pull these arrows up and create more tangency. We'll select the arc as the guide curve, and then the other option we'll select is merge tangent faces. All 3 of the faces will be merged together to create one helper surface. To finish off the tip, we're going to use a fill surface to fill in the area here. Now a fill surface doesn't necessarily require a sketch. We can use, in this case, the edges that create the boundary that we see here. So we've got actually 5 edges that we'll need to select. The edge settings, we'll just use alternate face and tangent. There are no other options that we need to set. And we can say OK to that. And now we've got a nice smooth surface to finish off the tip. Once we have completed this portion of the surface modeling, we can now actually delete those helper surfaces because we're not going to be utilizing them any further. In here we're just going to be using delete face, so we would go into surfaces and use the delete face. The reason why we did that is because now we have this portion of the surface model which is just now split where we would consider the split line in the forging process. Forging is something similar to a cast process, but a forging is created by actually pounding superheated metal into a form.